All right, let's talk about something in the National Electrical Code that trips a lot of people up: autotransformer grounding. Now, I know it sounds super technical, but trust me, getting this right is absolutely critical for a safe installation.
So let's just kick things off with a question. What's the one single connection that can literally be the difference between a system that runs smoothly and a total electrical disaster? Well, the answer is buried deep in the code, and we're about to dig it out.
Okay, so first things first, before we even get into the weeds on the rule itself, we have to understand the why behind it. We need to get a handle on the unique risk that autotransformers bring to the table. So what is an autotransformer? At its core, it's just a different type of transformer. But the key phrase here is only one winding. See, a normal transformer has two separate coils, a primary and a secondary. An autotransformer? Nope. It uses one single shared winding for everything. That's the whole ballgame right there. To make that a little easier to picture, think about plumbing for a second. Imagine you have one shared pipe for two different systems. If some nasty contaminant gets into one side, what happens? There's nothing to stop it from getting to the other side, right? That is exactly the same idea here, just with electricity. And this chart really lays it out perfectly. On the left, a standard transformer with its separate windings gives you what's called electrical isolation. It's like a buffer, but look at the autotransformer side. That single shared winding means you get zero electrical isolation. And that one detail, that's the whole reason this special grounding rule even exists.
All right, so now that we get the danger, let's talk about the rule. We're going to look at NEC section 215.11. This is the big one, the safety net that the code puts in place to deal with the risk we just talked about.
Now here it is, the exact text from the code. And I know, it's a mouthful of code speak, but it's really important to see the precise language. Basically, it's saying you can't even use an autotransformer unless you make one very, very specific connection. So what does all that legalese actually mean in the real world? It boils down to this one simple, non-negotiable step. The grounded conductor, your ground wire, your neutral, from the system feeding the transformer, and the grounded conductor of the new system you're creating, they absolutely must be tied together. That's your safety link.
But as you know with the code, there are almost always exceptions. So let's look at the first one. This one covers some very specific and pretty common voltage changes.
The whole point of this exception is to make life a little easier for those small, everyday voltage adjustments, what we call bucking or boosting the voltage. It lets you skip that direct connection we just talked about. But, and this is a huge but, it only applies in two very specific cases. Case number one is when you're boosting the voltage from a 280-volt system up to 240 volts. That's it, a pretty common scenario. And as you'd expect, it also works the other way, bucking the voltage down from 240 to 208. If and only if your setup is one of these two exact situations, then you're allowed to use this exception. Otherwise, you're not, period.
Okay, now for exception number 2. And I really have to stress this. This one is way more restrictive. This is not for your typical job site. This is for highly controlled industrial environments only.
So this one is carved out specifically for high-voltage industrial systems, and it comes with a whole list of conditions that you have to meet. And you can't just pick and choose, you have to meet every single one of them.
It's basically a 3-part test. First, the gear has to be in an industrial facility. Second, the only people touching it can be qualified persons. We're talking trained, experienced pros. And third, there has to be a formal, guaranteed program of maintenance and supervision in place.
And if you can check all 3 of those boxes, then this exception applies to these specific high-voltage systems, transforming between 480 volts and 600 volts, either direction. That's it. It is a very, very narrow exception.
So we've gone through the main rule and the 2 really different exceptions. Let's just pull it all together. What is the one thing you really need to take away from all this?
Here it is. The default is always safety. Your go-to move, your standard operating procedure, should always be to connect the grounded conductors. That's the fundamental rule. The exceptions aren't loopholes, they're very specific permissions for pros who know exactly what they're doing. So when in doubt, make that connection. And that really leaves us with one last thought. The code. It can give us the rules, right? The black and white text that we have to follow. But what it can't give us is judgment. It can't provide the experience and the caution to apply those rules correctly out there in the real world. That part,
well, that part's on you. Thanks for joining me.